Converting a fraction to a decimal is not a very hard task as long as you have one skill, and that is knowing how to divide fractions. So when we are converting a fraction to a decimal, we literally are just taking each fraction and dividing it. So here I have 3 examples of what that could look like. So taking 5/8 and turning it into a decimal. I'm going to take the 5 and divide it by 8. One of the things that is harder to remember for some people is which of the numbers goes inside the division box and which one stays outside. The 5, the numerator, is what goes inside. The 8, the denominator, is what goes outside. And I always imagine the fraction just kind of toppling over. So the 5 ends up farther away, the 8 ends up closer. Now, 8 does not actually go into 5 because 8 is bigger than 5. So there is a hidden decimal point after that 5. And we're going to transfer that decimal point up to the top there so we know where our decimals are going to be. And if you remember, when we divide, you have to add zeros if the number will not go into the other number. So 8 will now go into 50. How many times does that happen? 8 times 6 would be 48. So it goes in 48 times, but that's not exactly 50. There's a remainder of 2, okay? 8 does not go into 2 either, so we have to put another 0 to drop down here. Okay, that's going to give us another decimal place, basically. 8 goes into 20 how many times? Well, 8 will only go into 2 times for a total of 16. Again, that doesn't exactly equal 20. We're left over with 4. So we need to add another 0, which basically adds another decimal to our number. Okay, so you can see that so far 5/8 is 0.62. I don't know how far it's going to go from there, but I know that I have to keep going until I find a number that goes in evenly. For instance, here, 8 goes into 40 exactly 5 times. That's going to be the last decimal number for this question here. So 5/8 becomes 0.625. That's the thousandths place, so this is 625 thousandths is how we could read that. Okay, same thing if the number is negative, the fraction is negative, that means the decimal is going to be negative too. You can kind of just leave off the negative while you do the division problem. Okay, so same thing, 9 won't go into 2, so we're going to set up our decimals. 9 will go into 20, okay, that will give me 2. 2 times 9 is 18, so it didn't go in evenly. I'm left over with 2 again. Drop 0. 9 goes into 20. Oh, I'm at the same spot. 9 goes into 20, 2 times still. I get 18. I'm left over with 2. And at some point, you'll start realizing that this is just going to keep going and going forever and ever. I'm constantly going to be getting 20 minus 18 to get 2. And no matter how many zeros I drop, that's not going to change. So there's a point where you can say, you know what, this is going to be a repeating decimal. It's just going to be 0.22222, and you can add the ... to the top there to show that the 2's keep going forever and ever. In fact, you could just write 0.2 with a line over the top to show that it's just 2 repeating. You could also write it something like this, ... You could have stopped after just a couple of 2's. Once you realize that you're going to end up with a repeating decimal, you can stop the division. So far we have 2 different kinds here. We had this fraction, which ended up being a terminating decimal, and the division was actually able to stop. And this one, where the division would have kept going forever and ever and ever and ever, and so we had to just stop it ourselves and say, okay, this is going to be 0.2 repeating. Let's see what this one ends up being. 17 over 11. Do you think this will be what we call terminating or what we call repeating? Let's see what happens with 17 divided by 11. Now, 17 is bigger than 11, so we actually can take 11 and put it into 17. It'll go in 1 time with a remainder of 6. Okay, but we have a remainder, so we have to keep going. So the decimal point goes right here. So we had a number before the decimal point this time. It means there was a whole number. And now we're going to figure out the rest of this decimal. 11 won't go into 6, so I'm going to have to drop 0 to give myself more decimal places. 11 will go into 60 5 times. That'll give me 55. That's a remainder of 5. I'll need to drop another 0. 11 will go into 50 4 times. 4 times 11 is 44. That's a remainder of 6. drop a 0, and you'll notice I have 60 again, just like I had up here. And from this point on, I should see things start to repeat because I'm going to end up in the same pattern. 11 will go into 60 5 times. That's 55 with a remainder of 5. If I drop another 0, look at that. 11 goes into 50 4 times. 1.5454, it's going to continue doing 5454 for the rest of time. So I can stop at this point and just say, you know what, this is going to keep repeating. Okay, now these dots right here, by the way, I should clarify, they don't mean that this keeps repeating. They mean that this keeps going. Okay, so if we really want to show this correctly, we would say that the answer here is 1.54, and then put a line over the 5 and the 4 to say that the 5, 4 repeat over and over and over again. Okay. If I were to see a decimal like this, I would assume that this is saying that 5, 4, 5, 4 repeat. Same as this, I would assume that the 2 keeps repeating. But the technically correct way would be to write it with the line over the part that is going to repeat. Okay, so that is converting fractions to decimals.